Hey everybody, we're continuing the 4-5 graph of a rational function. So on this one, we have 18x squared over 3x squared because you can kind of ignore that other stuff. And when you do that, you do your ratio 18x squared over 3x squared and get 6. So that's going to be your horizontal asymptote. So what I just did was this part right there. So that's the y equals 6. Okay. On the other part for the domain, what we need to do is set our denominator equal to 0. So 3x squared minus 22x plus 24 equals 0. So we might just want to graph this. I think that'd be the easiest approach. So keep in mind, I'm only graphing the denominator. Only graphing denominator right now, at the moment. So 3x squared minus 22x plus 24. So those are your answers. So we do analyze graph, then 0. And so that gives you 1.3 repeat. And then the other one, analyze 0. That one gives you 6, 0. Whoops, drop. So those are our two that we want. Now, if you don't know what that fraction is, even though it's got a few choices here, you can go 1 point and then type a bunch of 3's in about halfway, then do menu number fraction, and there's 4/3. So 4/3 and 6 are where it's undefined. Now, at the moment, I don't know if both of those are vertical asymptotes or just one of them. But based on it being undefined, that's what we want. Okay, so now what I'm going to do is I'm going to go back to my document, and I'm actually going to put a parentheses around it, and that's now going to be my denominator. And I'm going to do another backwards parentheses and type the numerator in. 18x squared minus 9x minus 20. And what I need between there is a divide by sign. Okay, so now for this part, graph the numerator and denominator. And if I do my window similar to what these are, I would either use -12 or -24 for my X-Men. And, you know, basically those for the X-Men, 12 or 24 for the X-Max. And same idea for the Ys. Same for the Ys, or Y values. Okay, so let's see how it looks. Menu for 1. So menu for 1. And I'm going to set it first to the -12. to 12 for both, and it looks like that, which isn't enough. We see part of it, but we don't see everything. So now let's change that to be negative 24 to 24. And now we have two parts. So based on that, you only have one vertical asymptote, and it's probably the x equals 6 based on 4/3 already being passed. So we can go to your table. Sure enough, 6 is undefined. Now for those that like to only use the table, you can't see 4/3 in here undefined. So you'd have to do another way. I don't even think this part is worth it, but I'm still going to show you because it just takes a minute. We could have started our table at 0 and went by 1/3. So that means you have 1/3, 2/3, 3/3, 4/3, and that's undefined. Maybe that is useful, but for the most part, y'all usually keep your step as a whole number. But I guess it just depends on the problem. So that's a skill you may need later. I know you'll need it when we do trig, but I'll remind you again then. So it's definitely going to be the negative 24 to 24, which is this one, like that. Okay, and it's definitely the 6. Now, if we want to be more technical, we could actually factor both. I don't know if that really buys us too much. It's probably not worth it. I think you just check the graph and see there's only one. That's probably the easiest way for y'all. Okay. On this next one, we have x squared plus 14x plus 48. Now this one does look like you can factor it kind of easy, because like one of the most common math facts from elementary is 6 times 8 is 48, and then 6 plus 8 is 14. So that can actually be factored pretty easily into x plus 6 times x plus 8, and the denominator stays x plus 6. So I would just say, if it's easy to factor, go ahead and do it, because now you can see this cancels, which is going to be a whole, which means this part is going to be your answer right over here, where it says x plus 8. So that's kind of useful. Now it's undefined only at the negative 6, because you would say x plus 6 equals 0, x is negative 6. In this one, there's not going to be a vertical asymptote because there's a slant. So if you graph this, x squared plus 14x plus 48, all of that divide by x plus 6 in parentheses, it's just a straight line. And if you think about it, if it was x plus 8, then that means that we can change this to be 20, and you'll see it's crossing at 8. You can go to your table at 0, 8. So there's not a vertical asymptote. It's just a slanted line. So just like slope of 1, y-intercept 8, and it's that one. Okay. Now on number 12, okay, we have this one and one more. On this one, we want to know our domain. And if you just break it into parts, x plus 33 over x cubed, this part is all reals, but this part is x naught 0. So the whole thing has to be x naught 0. If you want to graph that, you get x plus 33 over x to the third power, which looks like that. So we do have a vertical asymptote, and let's look in the table. Okay, so we can see it's at 0 where it's undefined. So that would make sense. Vertical asymptote at x equals 0. Now, the graph, when we get down to the choices on this, it looks like you want -6 to 6 for x and -12 to 12 for y. So let's graph it. Change our window. So we do menu 4, 1, -6 to 6, and -12 to 12. So that looks like that. So that's the B graph. Now for our horizontal asymptote, since it was x plus 33 over x cubed, this part's going to be the horizontal asymptote. Wait, I didn't mean horizontal. For the slanted asymptote. Slant. That's the y equal x. So if you want to confirm that to see if it makes sense, you can press tab and press X, and there it is. So it's kind of like a magnet drawing towards the horizontal asymptote. I keep saying that. Towards the slanted asymptote. And your vertical one is at x equals 0. Okay, so that's how you do that one. And on our last one, it's multiple choice. You want to know which function out of these could possibly be it. And so let's just look at it from left to right. So let's see. It looks like that at -1, there could be a 0. This one would be much easier on the computer because I can't zoom in. 1, 2, 3, 4. It looks like we have a vertical asymptote at x equal 4 and a vertical asymptote at x equal -1 based on where the dashed lines are. So I would just go through the choices. Let's go to the first one. X minus 1 squared times x minus 7 times x plus 1. All of that divide by, remember we do an extra parentheses. So x plus 1 and x minus 4. Okay, so that one looks like that, which does not match that graph. So it's not A. Then let's try B. X minus 1 times x minus 7 times x squared plus 1. Oops, that needs a parentheses as well. Okay, so all of that divide by parentheses x plus 1 squared times x minus 4 squared. Okay, so then there's the graph, and sure enough, it goes up, it goes down here, and then it goes to the side. So that's the correct choice. Okay, hope that helps. Have a good day.